Today you are going to work with finding the area of something called a composite figure. A composite figure is a shape that is made up of combinations of other shapes. So a composite figure could have any of the following in it. It could have quadrilaterals, and we know how to find the area of several different quadrilaterals. So it could be things like a square, a rectangle, a parallelogram, or a trapezoid. We have learned about all of those different ones at different points this year, several of them recently. It could also include circles or what's called a semicircle. And a semicircle is just a half circle. So find the area of the circle and then chop it in half. So it could have quadrilaterals, it could have circles or semicircles, or it could also have triangles. The trick to finding an area of a composite figure is to break it apart into these different shapes, because these different shapes individually we know how to find the area of. So it's kind of using everything we know about area all at once. And if we find the area of each of the pieces, then when we're done, we can just add the pieces back together. Sometimes we have to do a little bit of quick calculation or looking at a diagram in order to get the information we need. We'll talk more about that with the examples that we're going to look at right now. So we're going to look at a few examples just to kind of give you an idea of how this works. So this first composite figure, so the trick is to divide it up into shapes that we can find the area of. And you want to try and divide it into as few shapes as you can. So like I could divide this into a triangle and a square and a rectangle, but it would be faster to just do a triangle and a rectangle, because then I only have two shapes instead of three. So you want to try and do as few shapes as you possibly can. So if I split the shapes apart, I need to make sure that I know all of the information to find the area of those shapes. So if I look at the rectangle and the triangle separately, the rectangle, I know the bottom is 12 feet and the side is 4 feet. So I know everything I need to know to find the area of the rectangle, because the area of the rectangle is just length times width. So I can do 12 times 4, which is 48, and that gives me the area of the rectangle. So I know that piece is 48. We'll deal with units when we're done. Now, the triangle. In order to find the area of the triangle, I need to know the base and the height. Now, where this gets a little bit tricky is that these things are not directly labeled. So sometimes you have to do a little bit of looking at pieces and doing some quick subtraction to figure out what we need. So if I look along this left side, I know that this entire length in blue is 10 feet. And I know that this is 4 feet. But if that's 4 feet, I could carry that over to the other side. So that's also 4 feet. But what I actually need is this piece up here. So I have to do a little bit of quick math and say, okay, if the bottom of it is 4 feet, the red part, and the whole thing is 10 feet, then the top must be 6, because 4 plus 6 makes the total of 10, or 10 minus 4 is 6. So sometimes you have to do a little bit of quick calculation. The same thing is going to happen the other way. I'm going to erase some stuff just to get it out of the way here. So I have a similar thing going on the other direction. So I need to figure out how long this piece is, the base of the triangle, but that's not directly labeled. What I do know is that this entire bottom edge is 12 feet. And I've got this piece over here that's 8 feet. So 8 feet plus what I need makes 12 feet. So that means that this part must be 4 feet. So if I pull it out, I'm going to label it down here, because 8 plus 4 makes 12, or 12 minus 8 is 4. So sometimes you have to do a little bit of a quick looking at what you have to figure out what you need if it's not directly labeled on the diagram. So now I do have what I need to figure out the area of the triangle. So we know that the area of the triangle is base times height divided by 2. So if I do 6 times 4, that gives me 24, but then I have to divide it by 2 because it's a triangle, not a rectangle, which gives me 12. So the top part's 48 and this triangle is 12. So if I go ahead and add those together, now I can put the pieces together and that'll give me the total area of the whole original figure. Well, 48 plus 12 is 60. And now I should label my units on my answer. Since I was measuring in feet, my answer is going to be, you can label it either as square feet or as feet squared. It's the same thing. But make sure that you're taking the time to correctly label your area units on your work. So let's look at the next one. So this one looks like we can come right along here, and if we cut this off, we can divide this into a rectangle and a semicircle or a half circle. So kind of go like this to keep our work separated. We can deal with the rectangle first because we have everything we need labeled for the rectangle. The bottom of the rectangle is 9.2 centimeters. The side is 1.5. So if I do length times width, 1.5 times 9.2, that will give me the area of the rectangle. And that gives me an answer of 13.8. That was not a very good 3. So that is the area of this. Now the top part of this is a half of a circle. So what we need to do is we need to start by finding the area of the entire circle. And then once we have the area, we can just chop it in half, since what we actually want is half of the circle. So to find the area of a circle, we need to know what the radius is. So we need this measurement. So we actually don't have that labeled at all. What we can figure out is we can start by figuring out the diameter. So we can figure out the length of this blue line, and then we can just divide that by 2, and that gives us the radius. So if the whole distance across the bottom is 9.2 and this part is 2.5, then that means the leftover must be the diameter of the circle. So from here to here, circle diameter. So if I do 9.2 minus 2.5, so basically take this whole length and take out the 2.5 piece, then I get 6.7. Now that's the diameter of the circle. So I'm going to have to divide that in half to get the radius. So I get a radius of 3.35. And we know from when we did area of a circle, actually in our last lesson, that the area formula is pi, which is 3.14, is what we use for pi, times the radius squared. So times 3.35 squared. And remember, that does not mean 3.35 times 2. It means 3.35 times 3.35. So if I do 3.35 times 3.35 times pi, which is 3.14, I get a pretty long decimal, so I'm going to round it off to the nearest tenth, since this was in tenths. So to the nearest tenth, my answer to this that I get is about 35.2. But the thing we have to remember is that is the whole circle. So now I have to divide by 2 because I want half of the circle. So if I take 35.2 and divide it by 2, I get about 17.6. And now I'm going to take that and I'm going to add my two parts together. So I'm going to add the 13.8 in with that. And that gives me an overall answer of about 31.4. And since we were measuring this in centimeters, my units would be square centimeters, or you can write it as centimeters squared. So that would be my final answer for that. So we're going to look at one more problem just to make sure you have the idea with how to split shapes apart. So this last problem, this is a deck. We're trying to find the area of a deck. So we can already kind of see that if we've got this little dashed line here, we can section this off into a trapezoid. And that kind of leaves this other part. So we could also come straight down here and we could section off a trapezoid on the other side. And then we're left with a rectangle in the middle. So we can split this shape apart into a trapezoid, a rectangle, and another trapezoid. So now we need to make sure that we have all of the different measures that we need for our shape. So the rectangle up here, we have this 20 feet labeled. So we know that that's one side of the rectangle. And then over here we have we have, we have 20 feet again, so that would be the height. So this is actually a square, not a rectangle, so we can tell that. So that gives us the information we need for what we just figured out is our square. So maybe it's not drawn completely to scale, but it actually is. So the trapezoid's on both sides. So we learned that to find the area of a trapezoid, we need to know both of the bases. So we need the lengths of both parallel sides and the height of the trapezoid. So if we start with the right trapezoid, this is turned on its side, but it does have a height of 10 feet, which you can see right there. So that's going to be 10. And we know that one of the parallel sides is 14. So we have to do a little bit of subtraction. Well, actually we don't. And the other side is 20. So this one is ready to go. We have everything we need there. But now we have to figure out our other trapezoid. We cannot assume that the trapezoids are the same size. So we have to kind of look across. So we know that so we need to figure out this bottom edge of the trapezoid. We know the whole thing is 36 feet. Now we also know a couple of pieces of that. So we know from here to here is 20 feet, and from here to here is 10 feet. So we can take out the 20 feet and the 10 feet from the 36 feet, and it'll leave us with the part that we're trying to find. So we're going to be taking out a total of 30 feet, 36 minus 30. So that means that this is not the same size as the other trapezoid, because this is going to end up being 6 feet. We can assume that this is the same height across. So if this is 14, we can assume that this is also 14. And we can assume, because this is a square, that if this is 20, this is also going to be 20. So we can assume that the parallel sides are the same height just by kind of looking across the diagram. It's that red part that we had to calculate. So now that we have all of our information, we can go through and find the area of each piece. We'll do the square first, because the square is pretty easy. To get the area of a square, it's just 20 times 20, which is 400. To find the area of a trapezoid, we said you have to add the bases, not turn it into a parallelogram. So add the bases and then do combined base times height, and then divide by 2, because a trapezoid is half of the double parallelogram. So if I do 20 plus 14, I get 34. And then 34 times 10 is 340. So that gives me the area of the two parallelograms that go together. So I would have to divide that by 2, because the trapezoid is half of that. Sorry, the two trapezoids go together to make a parallelogram. So 340 would be if I doubled the trapezoid, but I only have one trapezoid, so I have to divide that by 2. So that gives me 170 for that one. So now I have to come over and do my other trapezoids. So same thing. So I have to add 14 plus 20. That gives me 34. And then do 34 times 6, which gives me 204. And now I have to divide that in half, because 204 is the parallelogram that I get if I double the trapezoid. And that gives me 102. So now I can just take these three things and I can add them together. So I can do 102 plus 400 plus 170. And that gives me a grand total area, 672. And since I'm measuring in feet, my units would be square feet. So the area of the deck is 672 square feet. So hopefully tracking through these examples, first of all, gives you some good examples in your notes, and also gets you thinking about how you can take a complex shape and find the area of it by splitting apart into shapes that you know how to calculate. So when you're ready, you're going to